All right, welcome back. So we are going to be looking at example number 3 from the torque notes. So here we go. Let's get started. Remember, when we start, you always want to start with your givens. So the bar below is not rotating. Okay, so that tells us right away, guys, that the sum of the torques, sum of torque, is going to be equal to 0. Okay, so when there is no net torque, the object is not going to be rotating. It could be rotating at a constant speed or not rotating at all. Similar to acceleration, similar to the forces. When we talk about something that doesn't rotate. When the sum of the forces are 0, that means there's no acceleration. When the sum of the torques are 0, that means there's no angular acceleration. So the bar below is not rotating with all the forces being applied. Force 1, force 2, force 3. It has a hinge at A, so this is where it's rotating right here. Okay, so it's going to be it's not going to be rotating, but that's where it would rotate if it could. Force 1 is 10 newtons. Force 2 is 20 newtons. Force 3 is what we're trying to calculate here. We don't know what that is. We do know that the distance of force 2 from the pivot joint, so we'll say distance 1, the distance is 1 meter away from A. I'm sorry, I did that wrong. That's distance 2. Sorry about that, I read that wrong. Force 2 is 1 meter away from A, so let's put this down here, but next to force 2. So the distance of 1 is 1 meter. And force 3 is 2 meters from A, so distance for 3 is 2 meters. All right, next step is to draw our lever arms. So remember to draw, this is usually the hardest part, this is what people struggle with the most. So remember, when you draw a lever arm, you take the force and you extend it, okay, so that you can make a 90-degree angle from the pivot joint. Okay, so let's look at force 2. Well, force 1 is acting on the pivot joint, so we'd actually write that in here. Let's write that, this should be 2. The distance of 1 is actually 0 meters, so therefore the lever arm is going to be 0 meters, right? It's kind of like if you push on the hinge of a door, the door's not going to move. So force 1's not going to do anything. Force 2 here, so let's find the lever arm. So what we're going to do is we're going to extend this forward and backwards, okay, so that we can make a vector that creates a 90-degree angle to this line of force. So if I take it and put it right here, that's the 90-degree angle. That's 90 degrees right here. This is lever arm, so it's that D and this perpendicular symbol. That'd be lever arm of 2, like that. Now for 3, we get a different color here. We're going to extend this line of force backwards and forwards until we find a spot in which we will be able to make a 90-degree angle. It'll be right here. There it is. The lever arm of 3. So you can see our triangles here. We have one triangle here. Here's the 90-degree angle. Okay, and we have one triangle down here. This red triangle. You can kind of see it here, like that. Okay. So let's find our angles here. I like to use the angle that's across from the lever arm. So I'm gonna try to find. I'm gonna try to find this angle right here. Okay. This would be my theta 2. Okay. So to figure this out, this should be. I'm trying to extend this line down. If this right here is 35, that means our angle here, 90 minus 35, should be 55. So this should be 55 degrees. Okay, and let's find our the angle across from the lever arms right here. Okay, looking at geometry here, this would end up being the opposite angle, so theta 3 ends up being 65 degrees. Again, you can choose it whatever angle you want. I'm just using these angles because I like to use the angle that's opposite of the lever arm so I can use the sine function. So we're all set up. We have our lever arms and we have our angles. Now we can figure out our torques. Let's go ahead and do that. So just like we did before, start with our sum of the, just like we did with our forces. Let's start with the sum of the torques equaling 0. And we end with torque 1 plus torque 2. Be careful of signs now, guys. Well, torque 1 isn't going to rotate it, but you have to ask yourself, which way is it going to rotate it? Okay, and remember that if it rotates it clockwise, it's going to be a negative. If it rotates it counterclockwise, it's going to be a positive. That's just the way we do it. So force or torque 2, the force is pulling up. It's going to rotate it this way. It's pulling up. It's going to rotate it this way, which means it'll be a positive. That's why I have this positive. And torque 3, oops. Sorry about that. Torque 3 is going to rotate it. If you look at it, it's rotating down, which means it'll rotate the bar like this. Clockwise will be a negative. So my torque 3, I'll say plus a negative torque 3. And that's equal to 0. We know that the equation for torque is force times lever arm. So let's go ahead and break this up. Force of 1 times the lever arm of 1 plus force of 2 times the lever arm of 2 plus, let's throw a negative in here, negative force of 3 times lever arm 3. That's going to be equal to 0. Because I know that my lever arm is going to be 0 here for force or torque 1, that quantity is completely canceled out there. So that if I bring my get rid of this negative and bring this to the other side, I end with force 2, lever arm 2 is equal to force 3, lever arm 3. Okay, let's figure out what I'm trying to solve for here. I'm trying to solve for calculate force 3. So force 3 is going to end up on its own. So let's get rid of these lever arm quantities and actually put what our lever arm is. Using our sine functions, we know that lever arm, let's just take a look here, lever arm 2, okay, ends up being this distance here. Well, let's just look at this, the trig function. Sine of theta is opposite, so d2, lever arm 2, opposite over adjacent, which would just be d2. Remember this quantity right here is the distance of force 2 away from the pivot. Solving this for lever arm 2, you get d2 sine theta. So that's equal to d2 sine theta. See that? Same thing for 3. d3 sine theta. So let's put those in here right now. So I end up with force 2 times d2 sine of theta is equal to force 3 times, here, I'm going to show this quantity right there is equal to this lever arm. D3 times F3 times D3 sine theta. So now we can solve for the force 3. Let me just keep this in terms of variables. So I get force 2 times D2 sine theta over D3 sine theta. And we have everything. Let's take a look and make sure we got everything. We have force 2 right here, so we're good there. D2 is right there, it's 1. Theta is 55. D3 is 2. And theta is 65. Solving this for this, you should get, double checking the work. I noticed that the answer on here is off by a little bit. You end up with a force 3 being 9.04 newtons rather than 9.08. So again, the steps here, figure out what you know, draw your lever arms. This looks a little sloppy here, but draw your lever arms. Here they are right there. There's one, and the other one's this red one right down here, right here. Those are your two lever arms. Figure out your lever arms, and figure out what you need to solve from your some net torque equation, and you should be able to solve for it and get an answer. All right, thank you. Have a good day.